So right now we will be solving the valid palindrome problem. And to do this, a palindrome is where you reverse a string. So you reverse this entire string, and it is the same thing as going forward. So going backwards, reading it backwards is the same as reading it forwards. And this would not be including any spaces or commas, so anything that is not alphanumeric. And that is how you'd go about that. So you'd return true if it's the same going forward as the same going backwards. So a solution that you'd think maybe to do is just have create another string that reverses this string. So you'd have a string that's the exact opposite. And if it's the same as going forward as opposite, so you'd be comparing two different strings, then that would be one way to do it. But this is not an optimal approach. We'd want to use two separate pointers, your left pointer and your right pointer. And then with this, you would start and you would compare and see if any of them, your values are alphanumeric or non-alphanumeric values or spaces. So you'd go through the entire string and you would want to check if your left pointer is less than your right pointer. That's when you would end. And I don't know exactly where in this string it is, but if your value is in the middle and crosses each other, that is where you would end your problem. So now to go through this, let's just demonstrate it with this first problem. So start, your left pointer is here, and then your right pointer is here. You'd want to check, go through, make your characters lowercase. So you would check and change them to lowercase. So A equals A. If this is true, then you continue through the loop. And if it is false, you return false. So this is true, then you go to the next value. Now your next value is here and here. You want to get rid of anything that is not alphanumeric, so you'd have another while loop to get rid of non-alphanumeric values, and you just pass over it. So then this is not a alphanumeric value, so you move your pointer to the next value. And then you're comparing M to M and changing them to lowercase. They don't need to be changed to lowercase in this case, but M to M is true. Continue down. Next pointer's here and here. Then A is true, so you continue. N and N, they are the same, so you continue. And your comma is a non-alphanumeric value, so you continue through. So that was there. And then this is not alphanumeric, and then this is also not alphanumeric, so you continue to A. Those are both equal to each other, so you continue in the while loop. This is non-alphanumeric, so you just pass through, and then P, and change this one to lowercase. They're the same, so you continue through, and then non-alphanumeric, so you continue past that, and then L equals L, continue A, and then N, and then continuing through, so you get N, and get rid of those, so A, and then get rid of that, and then C, and then that's the last value, and then L, in the next case, L is not less than R, so you get out of that while loop, and then that means your value is a valid palindrome, and you'd return true. So in the case that it doesn't get to the end, you'd have like an if statement to check if the values, if your current left index is equal to your current right index, the value at those indices, and then you'd return false if that's not the case. And that is how you go about the valid palindrome problem. So now to get into the coding portion, let's go do that. To solve for the valid palindrome problem in C++, we'd start with the two left and right pointers. So int L equals 0, and then int R equals s dot length minus 1. Okay, so then you'd want to go, and then while the left pointer is less than the right pointer, you'd want to continue through the loop, and then either exit out if it's false, or return true after the loop. So we'd want to return true if it's successfully able to get all the way through the entire string without exiting. And that means it's a valid palindrome. So we'd first want to check and make sure it's an alphanumeric value, and then you'd want to also check if if the values in the left and right pointer of the string is lowercase. So first off, we'd want to check. So if not, so is not alphanumeric, and then your left pointer. And then you just want to do L++. And then you do the same thing for the right pointer, except right, you'd want to go the other direction. So you're doing right minus minus. And then you'd want to do if too lower. You'd want to check if the values are lowercase, so you just compare lowercase, just change them to lowercase no matter what. Doesn't really matter if they are lowercase or not, so we'll just do it like that, and then you want to compare it to lower of the right index. And so if these are not equal to each other, that means it's not a valid palindrome and it's not correct. So yeah. Then you'd want to return false, as it's not a valid palindrome. And then, so if your values are true and they equal to each other, then you'd want to continue and increment the indices, either left or right. And then that is how you do that. However, you'd want to compare in the first and second while loop. If your palindrome has values and the alphanumeric crosses each other, you'd want to compare left is less than right as well in here, because you don't want it checking a value that's not there. Yeah, that is how you do that. And let's see if that works. Run. And submit. Okay, so we have our solution, and that is how you do it.